isipan. Sa science o agham, tayo na sa sineskwela. Buksasin natin ang silensya, buksan ang pag-iisip. Tayo'y likas na scientist. Tayo na sa sineskwela, buksasin natin ang silensya. Kinabukasan ng ating bayan, siguradong makakamtan.
Good day everyone, do you want to learn about series circuits? If yes, this video lecture is for you. We will be discussing about series circuits and we will provide a sample problem for you to solve on. And make sure that you are listening carefully and following the steps when solving. Now what are you waiting for? Prepare yourselves, grab pen and paper, and let's start the discussion.
But first we must learn what is series circuits. Series circuit is a type of circuit that its current has only one path to pass through. Its resistors are arranged in a chain, like this.
So before we went through and know about the true laws of series circuits, we must always bear in mind its formulas, wherein V is equal to intensity multiplied to resistance, I is equal to voltage over resistance, and lastly, R is equal to voltage over intensity.
The first law states that the current passing through each resistor is the same as the current passing through the combination, or the total intensity or current is equals to I sub 1 equals I sub 2 equals I sub 3.
The second law states that the sum of the voltages across the different resistance is equal to the voltage across the whole combination, or total voltages is equal to V sub 1 plus V sub 2 plus V sub 3 and so on.
The third law states that the total resistance of the combination is equal to the sum of the separate resistance, or the total resistance is equal to R sub 1 plus R sub 2 plus R sub 3 and so on.
Now that you are ready to learn and solve word problems about series circuit, let's take a look at this problem. A 75 ohms, 26 ohms, and a 40 ohms resistors that are connected in a series with a 90 volts battery. First, we find the current through combination, and we must find the volts through each branch.
So in this kind of problem, what we have to do first is to solve for the total resistance. So by solving the total resistance, we will follow the third law of the series circuit. So all we need to do is to sum up the three given resistors, which are 75 ohms plus 26 ohms plus 40 ohms. And by adding that up, we will have 141 ohms. Therefore, the total resistance is 141 ohms.
Now it's time to solve for the missing current, where I is equal to volts over resistance, where volts is 90 and the total resistance is 141 ohms. Therefore, I 90 volts divided by 141 is equals to 0.64, and so the total intensity or current is 0.64 amperes.
Since the total intensity or current is equals to I sub 1 equals to I sub 2 and I sub 3, and the total intensity is 0.64 ampere, therefore, I sub 1, 2, and 3 is equals to 0.64. Also, since the first law states that the current passing through each resistance is the same as the current passing through the combination, meaning the current should be the same as the total intensity or current.
Now we have solved for the current, we must take the next step to solve for the final problem. Find the number of volts. And in this process, we will use the formula V equals intensity multiplied to resistance.
Always remember that you can only pair the same subscript value.
V sub 1 is equal to I sub 1 multiplied to R sub 1, wherein our I sub 1 is equal to 0.64 amps and our R sub 1 is equal to 75 ohms. When we multiply these two values, we will have, that's right, we will have 48 volts. So therefore, our V sub 1 is equal to 48 volts.
I sub 2 multiplied to R sub 2, where I sub 2 is 0.64 ampere multiplied to R sub 2, which is 26 ohms. Therefore, the product of V sub 2 is 16.64 or 16.64 volts.
V sub 3 is equals to I sub 3 multiplied to R sub 3, where I sub 3 is 0.64 ampere multiplied to R sub 3, which is 40 ohms. Therefore, the product of V sub 3 is 25.6 volts.
How do I begin? Hello? Okay. Good day, everyone. Hi, so awkward. But since we are done with all the definitions, with all the mathematical equations, with all the problem solving, let us now proceed to insert drum roll. Mary's Educational Vlog Part 1. So, usually found in our appliances around home, series circuits are designed to perform only one main task, and series circuits are usually composed of two main elements beyond the circuit breaker, which are the switch and the element controlled by the switch. So without further ado, let's get through my examples. Good morning. So, I still haven't taken a bath and I realized how musty I am. But anyways, let us now proceed to what I've said earlier. Let us now proceed to the real life example of series circuits. So, before we start, let me just have a sip of my coffee. Actually, coffee is one of the best example of the series circuits. No, not the coffee itself, but the appliance I've used to make coffee, which is a water heater. So, my mom might get mad at me for stealing this from her kitchen. But anyways, let's start. How do the water heaters uses a series circuit? So, let me explain why. So, the power enters the thermostat, which is a temperature control switch, and then when the water inside the water heater reaches the correct temperature, the thermostat or the temperature control switch will automatically cut off the current to the heating element. So that will leave the current with no other paths to follow. So that's why it is a series circuit. Now let's continue my coffee. You should eat your breakfast too. Hindi ako pa full ah. So, unang araw pa lang binahanda kita. Now let's proceed to my other examples. And I'm back to the second example. So the second example is, let's have a riddle. It is something that we turned on only at night but turned off at night. That's so easy. And it is a lamp. So actually this is a very ancient lamp we own. It's still from, I think I have this since I was a kid, and I haven't turned it on, though it still powers, but because it's very pricey when it comes to electricity. And it's very ancient, so I don't want to lose it. So, why am I explaining a lot of things? So, how does a power lamp operate a series circuit? So, let me explain. So, the power flows from the receptacle to the switch, which is this one. And from the switch, it flows through the light bulb and back to the receptacle. So, when the switch is turned on, the current flows through the light bulb. So, it turned on. And the current only flows through one path, just like a series circuit. So, that is why a lampshade or a table lamp is considered as something that uses a series circuit. So, let us now proceed to my partner. This is actually a collaboration with Mr. Archie Arquisola. So, let us proceed to his vlogs. Bye!
Hi guys, Archie Arquisola here, and in this quick video I'm gonna show you an example of series circuit that I have in this room. Before I'm gonna reveal this example, I'm gonna give you a hint of what it is. It gives light into my room, colorful lights, and you can usually see this on TikTok videos. I wanna see it, and I'm gonna reveal in 5, 4, 3, 2, 1. Yep, that's right, those are LED lights. I'm gonna give you a closer look. Just wait a second. LED lights or strip lights is actually a perfect example of series circuit, because series circuit is a type of circuit that its current has only one path to pass through. Now let's talk about why these strip lights or LED lights of mine is considered series circuit. And by the way, these are two different sets that is connected. Let me show you. And that is the connector that connects to the other part of the strip light or the second part. And what if I detach this? Charan! The other part here is off and here is still on because it is still connected to the main source of current. Alright, that is all for today. Thank you for listening to our mini vlog about series circuits. Hope you like our video and I hope you have learned things about series circuits from us. Thank you.